Hello students, welcome to my Abhyas. My name is Sahana KS and I am your physics educator. So in the last session we discussed some problems and we have discussed around 6 problems there, and today we'll be going with the 7th one. So there are around 20 of them. Okay, so we'll be solving all of them, and they are of different types, like it is based on all the topics whatever we have studied in electric charges and fields. Clear? So coming to the next question, what is it? Okay, so there is an electric dipole with the dipole moment 4 into 10 raised to minus 9 coulomb meter. So the dipole moment is how much? It is 4 into 10 raised to minus 9, and it is aligned at 30 degrees. So the alignment is 30 degrees. So with the direction of a uniform electric field of magnitude 5 into 10 raised to 4 Newton per coulomb. So what is happening? There is a uniform electric field of how much? It is 5 into 10 raised to 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. So I have to calculate the torque. For example, first thing, an electric dipole with dipole moment how much? 4 into 10 raised to minus 9 coulomb meter. So dipole moment is given by what? P. Okay. And then it is aligned at some angle which is 30 degrees with the direction of the uniform electric field which has a magnitude of 5 into 10 raised to 4. So I have to calculate the torque. So first write down what is given. This is the solution. So what is given? So the first factor which I have got is it is P. So that is P is equal to, that is magnetic dipole moment is equal to, dipole moment is equal to P, that is 4 into 10 raised to minus 9 coulomb meter. Clear? Moving on to the next, there is some angle theta which is 30 degrees, and after that we have the uniform electric field which has a magnitude of 5 into 10 raised to 4 Newton per coulomb. That is the magnitude of electric field, that is you can just take it as E is equal to how much? 5 into 10 raised to 4 Newton per coulomb. What should you find out? You have to find out the torque in that on that dipole. Okay, so the torque acting on the dipole you have to find out. So we know the formula of torque. Okay, so what is it? Tau is equal to, what you have to write? It is PE sine theta. Okay, so what is the P value? It is 4 into 10 raised to minus 9. What about the value of E? It is 5 into 10 raised to 4. Write it down. And then into sine 30 degrees. Clear? Any doubts in this? Okay. So PE sine theta, P is 4 into 10 raised to minus 9, E is 5 into 10 raised to 4, and theta is 30 degrees, so sine of 30 degrees. Solving this, what I will get? First is sine 30 is how much? 1 by 2. So just substitute 1 by 2 there, then it will become easy for you people to calculate. So it into 1 by 2. So 2 goes, here 2 goes. That is 2 ones are 2 twos are 5 twos are 10. Okay. 10 raised to 1 will be the thing, and then here you have minus 9 and here you have plus 4. So 10 raised to minus 9, 10 raised to plus 4 is 10 raised to minus 5. So 10 raised to minus 5 into 10 raised to 1 is how much? Minus 5 plus 1 is minus 4. So the answer will be 10 raised to 4 Newton meter, which is the SI unit of torque. Okay. So you can just see here, 5 twos are 10 I'll get. Okay, so 10 is nothing but 10 raised to 1. If it is 10 raised to 1, then minus 9 and plus 4 is minus 5. So minus 5 plus 1 is nothing but it is minus 4. Sorry, it is minus 4. 10 raised to minus 4 Newton meter. Clear? So this will give you around 5 marks easily, and there is nothing to worry about, because if you just put the formula whichever is pertaining to it or whichever goes with it correctly, then that is how you can get like 5 marks or 15 marks in the problem section without any like loss, right? So after this, next thing is we'll go with the next question. We'll just check what is the next question. Okay, a very important question which is based on the exact theory what you have studied. Okay, so coming to the question, a polythene piece which is rubbed with wool. So there is a polythene piece and it is rubbed with wool. So that as it is rubbed with wool, it is found to have a negative charge. Okay, so the polythene piece is negative. Okay, So as the polythene piece is negative, then wool will be obviously what? Positive. So wool is giving out the electrons to the polythene, and polythene is giving out electrons to the wool. Wool is giving the first thing, a polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 coulomb. So here what you can say, polythene is negative and wool is positive. So wool is giving out the electrons to the polythene and polythene is receiving it. So it gets negatively charged and wool is getting positively charged. So here what I have to do? First thing, estimate the number of electrons transferred. So how many electrons are transferred from the wool to the polythene? I have to check. And then, is there a transfer of mass from wool or polythene? So what happens, like whether wool is giving out or polythene is giving out, we have to just check. And how much mass has been transferred also we have to check. So what they have given me? They have given me only a charge value, that is 3 into 10 raised to minus 7 coulomb. So how to solve these things, or how to solve this solution? What they have given me? They have given me Q is equal to how much? 3 into 10 raised to minus 7 coulomb. So we have an equation which relates Q, that is the charge, and the electron, right? So that is nothing but it is Q is equal to N into E, right? Q is equal to N into V. We have studied this. So now what I have to find out is, I have to find out the number of electrons which has been transferred. So that time what happens? N becomes Q divided by E, right? So we know the value of Q, we have to know the value of E. So E mass is nothing but 9.1 into 10 raised to minus 31 kgs. So we'll be just putting the value and we'll be solving it. So the question, that is N is equal to Q by E, I will get. So that will be, okay. So, okay. Here N is equal to Q by E. Okay, so we know here N is equal to Q by E, where Q is the charge, value of the charge, magnitude of the charge you can say, and E is nothing but the magnitude of the electron. So magnitude of the electron is nothing but 1.6 into 10 raised to minus 19 coulomb. Similarly, the charge which I have got is 3 into 10 raised to minus 7 coulomb. I'll be substituting it. So that will be 3 into 10 raised to minus 7 divided by how much? 1.6 into 10 raised to minus 19. So solving this, what I'll get it around, so minus 19 goes up, it becomes plus 19, and plus 19 minus 7, how much you'll get? And here you have 3 and here I have 1.6. So by solving, I'll get it around 1.875 into 10 raised to 12. Okay. So this is it is a number. So there is no SI unit for this. What is it? It is a number. So no SI unit. So N is equal to Q by E, that is 3 into 10 raised to minus 7 divided by 1.6 into 10 raised to minus 19. Solve it. You will get around 1.875 into 10 raised to 12. Okay. No SI unit because it is the number of electrons getting transferred, okay, from wool to the polythene. Now, that is number of charges, you can say, number of charges moving from wool to the polythene. Next, is there a transfer of mass from wool or polythene? Yeah, there is a transfer. Because of the transfer only, what is happening? There you are getting the negatively charged particles and the positive charged particles, right? So negatively charged particles, in the sense it is receiving. So there is the transfer of electrons from wool to polythene. How much? We will have to check it. Okay. So how will you check it? So this is the 8th solution, and here I have the B solution. So what is the mass transferred? Because one electron, the mass of one electron is 9.1 into 10 raised to minus 31 kg. Okay. Charge is different, mass is different. Charge of the electron is 1.6 into 10 raised to minus 19. And what about the electron mass? It is 9.1 into 10 raised to minus 31 kg. So accordingly, I have to solve it. Like for 1.875 into 10 raised to 12 electrons, how much, if I multiply it with 9.1, then I will get the number of, or the mass, or how much charge is, or how much mass is transferred from wool to polythene. Clear? So here, coming to the next section, we will be just solving it, which is given by, that is the mass transferred. Okay, so the mass transferred will be equal to what we have, 1.875 into 10 raised to 12. Okay, so after 10 raised to 12 into what I have to do? Into the charge, that is the electron charge, which is 9.1 into 10 raised to minus 31 kg. Okay, so solving this, what you will get, because minus 31 plus 12 you have to do it, and then 1.875 into 9.1. Okay, so solving it, I get around 1.688 into 10 raised to minus 18 kg. Okay, if you solve it, you will get it. Okay, so 1.688 into 10 raised to minus 18 kgs of mass has been transferred from wool to polythene. Clear? So this is a process where you have learned, right, the charging by friction method. So whenever the two things are rubbed against each other because of friction, what happens? The electrons get shifted to the other particle, and that is nothing but we call it as charging by friction. So similarly, a problem which is based on charging by friction. So first what you have to do, you have to find out how much electrons have been transferred, that is the n number of electrons, and after that how much mass has been transferred. So for the number of electrons, you will be using the charge of an electron, and for the for the mass, you will be using the mass of the electron. Clear? So this much you have to keep in head. Whenever you just see charge and mass, you can just have that glimpse in your head. Clear? So moving on to the next question, we have the 9th one, and we will see how the question is. Coming to the first A, there is a sub question A. Two insulated charged copper spheres. So there are two insulated charged copper spheres, A and B. So there are two spheres which are taken as A, and another one is taken as B. Okay, so A and B are taken, and they have their separate, that is center separated by a distance of 50 centimeter. So the center is separated through how much? It is 50 centimeter. So what is the mutual force of electrostatic repulsion? So they have given me the force, which is a repulsive force. So repulsive force means you can just imagine that both the spheres are of the same charges. So here electrostatic repulsion, if the charge on each is how much? 6.5 into 10 raised to minus 7 coulomb. So this is 6.5 into 10 raised to minus 7 coulomb of charge is there on A also and also B. So next, the radii of A and B are negligible when compared to the distance between them. So second question, what I have to find out is, what is the force of repulsion if each sphere, so if there is a force of repulsion, if each sphere is charged double, if it is charged double, then what will be the force of repulsion, and also the distance between them I have to find out. So the distance, if the charges are doubled and if the distance is halved, what will be the answer? I have to just check it out. So coming to the solution section, first thing what I have to remember is, so what are the given quantities I have? The quantities which are given is, first one is the charge Q. Okay, the value of the charge Q, which is 6.5 into 10 raised to minus 7 coulomb I have got. Right, and then what they have said me, they have given me the distance between the centers, which is around 50 centimeters. So that is R is equal to 50 centimeter. 50 centimeter in the sense, if I convert it into meters, what happens? 50 into 10 raised to minus 2 meters, right? And this is equal to 0.5 meters if you solve it. Understood? So after this, you can know, like you can just have it like Q1 and Q2. So that is the value of Q, or Q1 and Q2 is nothing but it is 6.5 into 10 raised to minus 7. So instead of writing only Q1, I can just take it as Q1 and Q2, right? So I'll just take it as Q1 is equal to Q2 is equal to 6.5 into 10 raised to minus 7 coulomb.